Okay, guys, I added this page to the notes because I thought it was important for you to see more examples. So these are just for extra help, and I always think it's a good idea to get extra help. But um, at any point in time, if you don't like something or you're not sure, please, please, please don't be afraid to ask. Okay? Because I think the more you see of these, the better and easier it is to understand. Um, so yeah, so number one, first thing you're gonna do is I'm gonna see if I can reduce that fraction, and I can't because 23 divided by 9 gives me a decimal, and I don't want decimals. So I'm gonna simplify it by doing different roots. 23 is prime, like I said, so it doesn't break down, but 9 is 3 and 3. So that can come out. So the best simplified answer for number one is the square root of 23 over 3. Okay? Then moving on to number two. We're going to leave the negative sign out, and we're going to, again, 17 divided by 100 doesn't do anything. So I'm going to do negative square root of 17 over square root of 100, and 100 is 10 times 10. So the best answer for this one is negative square root of 17 over 10. Okay, number three, we're going to simplify by breaking it up into a top root and a bottom root. Okay, and then I'm going to make factor trees. 36 is 6 times 6, and z squared is z times z. So this ends up being 6 on top, nothing left inside the root, and z on bottom, nothing left inside the root there. Okay, number four is 4x squared over 64. So you can do a couple things. 4 and 64, they actually go into each other. So you can simplify at the beginning and get the square root of x squared over 16. Because if you do, in your calculator, if you do 64 divided by 4, kind of like you were reducing a fraction, you get 16. So that puts the 16 on bottom. And then you can split them. And you know that x squared is x times x, and 16 is 4 times 4. So you end up getting x over 4, okay? Or another way you can do that is you can just split it from the beginning. And when you do that with your factor trees, you get 2 and 2, and x and x. So on top you would have a 2 and an x, and on 64 is 8 times 8. So you'd get 2x over 8, but that fraction reduces to x over 4. I always think it's easier to reduce at the beginning so you're not working with big numbers and then you don't forget. But both ways work. Just remember to try to reduce when you can, okay? Number 5, we're going to notice that this n is 3. So I'm looking for groups of size 3. And 54 is 9 times 6. And 9 is 3 times 3. And 6 is 3 times 2. And I'm going to circle in groups of 3 because my root size is 3. So the 3's come out, and then the 2 stays inside. Number one thing I'm going to tell you, you're going to get marked wrong. Make sure that you always put the root size back in. If it's a 2, you don't have to, but anything else you need to put it back in or it's going to mark you wrong. Okay. Number 6, we're going to do the same thing. 16 is 4 times 4, which is 2 times 2 times 2 times 2. And I got one group of 3 and one left over. And then x to the 4th, I've got 4 of them, which means I make one group and one left over. So on the outside, I have a 2 and an x. And then inside, I have a 2 and an x. And I make sure to put the 3 in there because I'm doing groups of 3. Okay. 7, let's pick a fun color. That looks great. Okay. 7, I'm going to have a fraction, so I'm going to write it as 2 separate ones. Okay, I can't make a factor tree with the top, so the top's going to stay how it is. But remember in the notes how I said, if it's an odd root and you have a negative, that comes out. And then I have 3 times 9, which is 3 times 3, and so I have the 3's. So the top is going to stay the same, cube root of A, but on bottom, I'm going to take out the negative sign and a group of 3, and I don't have anything left over. Okay, and then I believe this is the last example. We're going to make it big so we can see it. Okay, we're going to go through and we're going to try, first thing we're going to do is we're going to separate them. So we're going to have the cube root of 25 c to the 7th d to the 3rd over the cube root of 64. So 25 breaks up to 5 and 5, and that's it. So none of that's going to come out. But c to the 7th, you can write out 7 c's if it makes you feel better, but I'm going to use division and go, okay, 3 goes into 7 2 times. So I'm going to get 2 groups of c, so I'm going to bring them out. And then I've got 1 left on the inside. So I'm going to kind of do this as I go. Okay, the 25 stayed in. I brought 2 groups of C out and I have 1 left in the inside, and then I have 3 D's, so I'm going to bring 1 of them out. Okay, so the better way to write that, that's what I would have on, would be C squared D over the cube root of 25C. Okay, if it helps you to go C, 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 that's okay. I'm okay with that, but you don't need to if you understand that you're figuring out how many groups, okay? And then on bottom, 64 is 8 times 8, which is 4 times 2, which is 4 times 2. And then we break those up, and I get a group of 2 and another group of 2. So I get 2 times 2 and nothing left on the inside. So I just get a 4 on bottom. I know it's messy, but that's the nicest way to do it. Okay. For future reference, just so you are aware, you might have these pages in your notes. We're not doing them. Okay, that is an honors topic, so you can ignore this page too if they're in there. I can't remember if they are or not, but don't worry about them. Same with this one. Don't worry about that one. We're going to start day 2, see where it says 4.1b in your packet or on when you are printing these off or whatever. This is where day 2 starts. So do the day 1 assignment and then don't worry about day 2 until day 2.